So, ones and zeros. So what I'm going to talk a little bit about first is how we can work out what kind of file we've got. Then a little bit about the problems and challenges of detecting text and languages. I'll talk a bit about Apache Tika and how we can use that to solve some of those problems. And then I'll talk about how it can all go wrong at scale and what you need to start thinking about if you've got more than a handful of documents. And also one of the interesting things we're doing in Tika at the moment, which is automatically trying to work out if things are getting better or worse as we make changes. So I can get a sense of what people are interested in and know which things to focus on. Who here is mostly interested in search stuff? Who here is more interested in the Hadoop, the Mesos, the Storm, that kind of thing, and doing a bit of data binary stuff on the side? Okay. Who here has used Tika before? Okay. Right. That's fine. So, detecting file types should be easy, right? So, if a file's on your computer, surely you know what it's going to be, and it's on your computer, so it's easy. And if it's not on your computer, well, you know, people never rename things, do they? And the internet, everything on the internet is right, isn't it? And web servers would never lie. They'd never get confused. A few % of the internet, it's not like that's worth worrying about. Operating systems, they never help. They never hide extensions, rename extensions, launch the wrong program. So yeah, it's easy, isn't it? So, file names normally, but not always, have extensions. But there aren't very many extension combinations. There's a lot more file formats than there are extensions, and there's no place that you can go to register or Bagsy your extension. So everyone just picks a sensible one and hopes that there aren't too many clashes. Who here uses Windows? Isn't it fun when you've got 3 different programs that all want the same extension? And isn't it fun when you rename something and all sorts of weird stuff happens? And so, file names are a really quick way to guess what a file type is, but it's pretty dirty and it's not always right. So if you've got 10 files, it's going to be close enough. If you've got 10 million files, it's going to cause issues. My magic, most file formats will have a well-known structure, and most of them will have a nearly unique pattern at the start. Sometimes these are called my magic numbers. Sometimes they are actual numbers, often it's just byte patterns or byte masks and things. Now ideally, every file would have a couple of unique bytes at the start that would let us work out what they are, or at least a couple of bytes at a known position that will give us a hint. So the PDF should start with %PDF dash, or sometimes though it starts with a byte order mark and then that, or sometimes even a few random bytes of crap and then that. OLE2 documents should start with that fun little number there. Zip files, PK 3.4, except when it's PK 1.2. AIF have a sort of mask structure here. PE executables probably going to have PE null lull at one of those 2 offsets, except when it doesn't. If your file starts 0xFFFE, that could be a UTF-16 little endian byte order mark, or it could be an MP3, or it could be a raw camera image file, or it could be something else. So, often, but not always, handy. Another challenge is, if you see a file that starts PK hex 3, hex 4, that could be a zip file. But it could also be an OOXML file, a .docx, a .xlsx, which is wrapped in a zip file. It could be an iWorks file, it could be an ODF file, it could be a whole bunch of other things. So just because we've got a magic number, it doesn't always uniquely identify the file format. And then if it's a text-based one, I had an interesting Tika bug this last week, which was, how do I tell if this is a MATLAB file or a C macro file? Because they're both text-based file formats, there's no header on the front, the comments aren't always great. So it can help, especially on binary files, but it's no magic bullet. So I've mentioned already container formats. If it's a zip, that's a challenge. Could be an OXML, .docx or something, open document, iWorks, pub, all that sort of thing. If you get one of the media container formats, like an OGG, like an MP4, it could be text, could be video, could be audio, could be combinations of them. And just because you found the MP4 magic number doesn't mean you can say, oh, that's music or that's video immediately. So it gets tricky to work out what's going on. There's also some fun stuff you can do if you like confusing people. You can build a Microsoft binary file, OLE2 structure, that has multiple streams in it, and then if you rename it from, say, XLS to doc, you get a different document that opens. It's a sort of fun little practical joke for stenographically hiding stuff, but kind of throws up some interesting problems where the file extension on Windows will cause it to open in different applications and show different information. So what can we do with containers if we're trying to make sense of them? Well, the easiest one is that we can use a mind magic to work out what container it is, and then we have to open it up and start looking through. So if it was a zip file and it contains an underscore rails.rails, it's probably OXML. If it's an OGG file, then we can look for a CMML stream and then pass that and start looking for descriptions that tell us what's going on. But this isn't quick. So when we had the file name stuff, if we found that it was .txt, we can very quickly say it's probably txt. If we found that it's an OGG stream, we now have to start parsing all the OGG packets, going through the page structure, finding the streams, finding the CMML stream, pass that, look in it, see what that tells us about whether this is going to be a video or an audio, and hence what parser you're going to use to get the text out, which is probably what you wanted in the first place. Because I'm assuming that most of you here, what you've got is a whole load of files, and what you want is a whole load of useful information. So you're going to have to choose how much work you put in, and that's going to be different for all of you. It's going to be different based on your needs. But sadly, it's not a quick thing. You've got to tune the dial based on the amount of memory, the amount of processing time to come up with the answer of what this thing is. And only once we know what it is, can we start getting the information out. Another one that you can sometimes do is look for patterns inside the file. There are some scientific data formats that don't appear to have any kind of known structure on them. So there's some work that's going on at the moment where people are using histogram patterns, and they analyze the whole file and they look for certain common repeating patterns and repeating structures and use that to work out what the file might be. That's also of use if you've maybe got corrupted files or truncated files. So if there's anyone in the audience who's doing any stuff around digital forensics, where you may have 80% of the file, if you've missed the first 128 bytes of it, you've missed all that lovely magic number stuff, so you won't have those there. And then you're looking at this data and you're going, well, is this most of a PDF, or is this most of a text file, or is just the hard disk is dead? So you can do some stuff around that. Finally, what you're probably going to want to do is combine all of them. You're going to take the file name and use that as a hint. You'll take the mind magic, use that as a hint. If you looked inside the file, that's another hint. It's going to have impacts on the speed and accuracy. Another thing that you maybe want to do is do a bit of machine learning and find out what's the right weighting for your target data set. That means a bit of work up front, because you're going to have to go through and say, yes, that really is a Word document, whereas that thing that claims it's a text file is actually a PDF, and then learn the right combination so that your system will predict that from the given inputs. Which can, I mean, yes, it's more work, but it can increase your accuracy, so it just depends on what you're going to care about. Okay, so that was for our binary stuff. What about text? Text is easy, isn't it? Who thinks text is easy? Good, the cynicism is working or you've fallen asleep. So, encodings 101. If you find a letter A in your file, or sorry, if you've got a letter A that you're going to be encoding, you could write it as 0x41, 0x0041, 0x4100. So those are all your kind of typical PC ASCII style formats. Or you could have a mainframe, in which case it's been written as 0xC1. So that's just the letter A. If you're dealing with a lot of old file formats, they're all going to be using 1 byte per character, which just remaps it all sorts of different ways. So if we find the first character in our file, text file is 0xe1, well, those are the most common characters that could actually be from the most common single byte encoding things. Some file formats are helpful, and they'll tell you what encoding the next stream of text is in. But if it's a plain text file or a lot of the email file formats and stuff, it's just a bunch of ones and zeros, and you've got to work out what that's going to be. So you can't actually extract the text from your text file until you know what encoding it's in. So how are we going to work out whether our file is going to be in Arabic or Hebrew or Greek or French? The good news is that you can often find the language and the encoding at the same time. So, if we see some accents like that, it's probably not going to be English. If we see lots of words starting with S, it's probably not going to be Spanish. On the other hand, if we see lots of words that start ES, it's much more likely to be Spanish. So what we can do, if we've got enough of a corpus of text available to us, we can go through and find these common patterns for certain languages, and we can find these common patterns for different encodings of the same language. And then we can use that. But we need a lot of text. If I have one sentence, it's going to be very hard to work out definitively what that is. If I have a lot of text, it's going to be easier. If I have mixtures, so if I've got this slide here, and I save that as a text file, some simple analysis tools might get confused and they'll go, oh look, there's all these accents in it, it can't be English. Well, it's mostly English, but I've put some accents in. But if I've got the whole presentation saved as a text file, then you can ignore those odd little rounding errors from the odd accent that I've put in and still work out most of what we've got. Okay, who knows what an engram is? Oh, excellent, everyone. Okay, so all I'll say then is if you've got enough text, you can build up the common engrams from each language. You can use tools like iconv, ICU4J, and that kind of thing to take your sample engrams, translate them into all the different encodings that you might be dealing with, and then you can do an engram match and say, aha, this is Spanish in ISO 88592 because that's the highest likelihood for these given engram patterns. And so then what we can end up with, when we started with something with a .txt extension that may or may not have been text, we can apply the engrams on it and go, ah, this is French in this encoding, this is German in this encoding, this is Korean in this 2-byte Eastern encoding, which then means we can read it in because we know what encoding it's in, so we know how to get the characters out, and we know what language it's in, which means that if we're going to be indexing it and searching based on it, we know what kind of analyzers and stemmers to apply to it, because if it's in French, you're going to need to use different techniques for breaking it down into words than if it was in Korean. So that's handy, because we can tackle both at the same time. There's a few things that it can go wrong with. If you've only got that tiny little bit of text, it's going to be hard to work out what it is. If we've got a load of control characters and garbage at the start of the file, you may mistakenly think it's not text. So again, that's for any of you in the room who are doing any forensic stuff or dealing with any weird files where a few random control characters end up on the front. You might think, oh, this is some random binary file when it's actually text. Some encodings are very similar. So the difference between ISO 88591 and 15 is, I believe, the euro symbol. So if you've not got any pricing information in there, you can't tell the difference between them. But on the other hand, if you've not got any pricing information in there, does it matter if you pick one or the other because you're not using that code point? So those are the techniques for working out what our binary files are and what our text files are. What about if you don't want to code all those up for yourself? So Apache Tika is like a Babel fish for content. It helps you work out what your file is. Then it helps you extract the metadata from it in a consistent way so that you don't need to know that a Word document calls it summary and a PDF calls it short title and an MP3 calls it title. You can say, Tika, find out what this file is and then tell me the thing that most closely matches the doubling core subject. And then Tika can go off and do that for you and give the information back. And for a lot of you in the room who are interested in search, it'll give you back nice, simple, plain text, which is handy. So these are some of the file formats that it's going to support out of the box. What Tika does on the whole is wrap other libraries so that you don't need to know that the best library for PDF is PDFbox. For a Word document, it's POI. On the whole, Tika doesn't have its own code for handling given file formats. What it tends to have is calls out to all the appropriate libraries that will do it for you. So it's got all your usual Office file formats and HTML and PDF and all that sort of stuff. But also increasingly, it's got a lot of scientific file formats supported in it, and then audio and video and image file formats as well. And it's got hooks into the Tesseract OCR tool, so that if you've got an image file, you can then hand that off to Tesseract, which will give you the text, and then you can give it to EXIF tool or something like that and get back the EXIF information. That will mean that you can work out that that particular photo was taken in front of Brandenburg Tor with someone wearing an I Love Berlin t-shirt on it. And so you can pull out the metadata and you can also get the text from it. Which is great because before you had that, you just had an image file and you couldn't index it and you couldn't do anything with it. And now all of a sudden you can say, give me all the images taken in Berlin that mention the word Berlin in them and get it that way. So, a few different ways of calling Tika. There's a command line tool. You can call it from Java. It's got OSGI bundles. It has a network server and it has a Solar plugin. Who here uses the Solar plugin for Tika? Okay. Don't put too much data through it because it's in the same JVM. So we're going to come on a bit later to the ways it can go horribly wrong. I was having a chat with some of the Solar committers last night, and they say that they absolutely love it for demos, and they absolutely hate it when it gets put into production because then it falls over and wrecks everything. So, who here writes stuff in Java? Who here writes stuff in a JVM language, not Java? Who here uses some other language? Okay. So for those of you not using Java, the main two ways I'd suggest you use are the Tika app and the network server. For those of you in Java, you can pick any of them, whichever one you prefer. So the Tika app is a single runnable jar. It's getting quite fat these days because it's got all of the dependencies bundled into it. But you just take it, you run it. It can give you the detection. So you can say, Tika, what is this file? If it's a text file, you can also do the language detection and say, you know, what encoding is this, what language is it? It'll give you all the metadata back. It'll give you the plain text and the XHTML. It's really good for testing. It's really good for demos. But you're spawning a new JVM each time. So if you're going to be running this thousands of times an hour on a handful of machines, that's maybe not going to work out so well because you're going to be paying maybe a second to spawn a JVM and then 15 milliseconds to pass the file. That's not necessarily going to be a great thing. But on the other hand, if your application is mostly dealing with simple plain text, and only very rarely you're going to get these binary files, maybe it is okay to spawn a new JVM once in a blue moon to pass the odd file and increase your coverage that way. It's a bit of a trade-off going on there. The Tikka server is a RESTful server. You just put files to it, and then it will give you back the results, be that the detection or the text or the metadata. So if you're running in a non-Java language and you're going to want to put a lot of stuff through, or even if you're running in a Java language and you want it in a separate JVM, so if it falls over it won't take out your main one, it's worth running the server. It's standalone, single jar, you run it, up comes the server, you start putting resources to it. But it's very easy to have a little watchdog that spots when that falls over and respawns it, and then that's completely separate from your main application. So if you are doing Solar and you're doing Elasticsearch at any kind of scale, the generally recommended way is you find that you've got a binary file, you post it to the Tikka server, get back the response, hand that off to your search engine, and then if it all goes horribly wrong, you've not just wiped out a third of your Elasticsearch cluster, which is not ideal. There's a fair bit of documentation available on the wiki about it. Or alternatively, if you just launch it and go to it in your web browser, it'll tell you in summary what all the endpoints are and what they do. For those of you who are running in Java and want something nice and simple, the Tikka Facade is the easiest way to call it. It has methods there that say, you know, I have an input stream and I want plain text. I have a file and I want XHTML. So you just, very simple method calls. The only downside of the Tikka Facade, because it's all nicely wrapped up in for you, is there's no easy way to say, did I forget to give you half the jars? What will happen is that you'll give Tikka an input stream and get back nothing. And the reason you got back nothing is you didn't have any of the required jars there to handle that file format. So Tikka will have worked out what it was and then said, well, this is a PDF and I've got no PDF libraries, so I can't help, sorry. The direct calling auto-detect parser with Tikka input streams with the Tikka config gives you full control, lets you do exactly what you want to do, and also you can ask the config object, what parsers did you find? What MIME types did you find? And if Tikka comes back and says, I know about 3 MIME types, and you'd be like, well, where did the other 1,400 MIME types go? Maybe we stuffed something up in the deployment. Or you ask it about what parsers it supports, and it comes back saying 3, not 70. Again, there's a reasonable chance that something went wrong in the deployment, and you can then fix that. As I mentioned, because Tikka wraps a lot of these other libraries for you, there's a lot of these dependencies that need to be present at runtime for it to work. And so a lot of the things that go wrong for people seem to be when their deployment system deploys Tikka and misses all the rest out. Another thing you might be interested in is the forked parser, which fires off a separate JVM to do the parsing, so that if something goes wrong with Tikka, it's a separate JVM that falls over, not your main one. Okay. Another thing to flag up about Tikka is it tries to be consistent across all the file formats, mapping all the different metadata onto their common things, giving you simple HTML back, simple plain text back. So the word parser will tell you that it's a table. It will tell you that this is a heading 1, but it won't do word style, save as HTML, all the bold, italic, random styling things, which is probably a good thing for most of you because you're mostly interested in search. But if you want to do a rich preview of the search results, be aware that some of that information will have been thrown away by default. And if you really need to show that that bit of text was in red, then you might need to use a different parser. I won't mention too much on extending Tikka, just to mention that if you have your own MIME types that aren't supported out of the box, you can just drop an extra file onto the class path and Tikka will pick that up and add in your new MIME types. And that Tikka has 70 formats with their own parsers available out of the box. And if you need to add a new one, it's only 13 lines of code plus whatever's required for your file format, which is going to be more work. But if there's a particular file format that you're dealing with a lot in your environment where you've maybe licensed in or written your own parser, your own library for dealing with that file format, it's fairly easy to then plug that into Tika and start indexing. Okay, quick note on embedded resources. It's not just containers. If you've got an Office document, you can put images in it. You can put other Office documents inside it. Tika will try and tell you where it found an embedded resource and give you a way to get that embedded resource. And it's then up to you how you handle it. Maybe you'll want to inline all the text from that embedded Office document in another Office document. Or maybe you want to treat them as separate resources and index them separately or store them separately. That's a choice that you can make. Okay, how does it all go wrong? Okay, so at scale, you're going to come across a lot of junk documents, a lot of corrupt documents, a lot of messed up documents. You're going to hit a lot of edge cases, and 1% of the internet is still a very large amount of data. So you're going to have to plan for files that are going to be misidentified, files that are going to trigger weird bugs in the libraries. Just going to have to plan for failure. So, as you're parsing your particular set of data, you're going to get a lot of files that are not supported, that haven't actually got any MIME type defined for them, maybe or some new type of file. So one thing I would suggest is if Tika can't work out what your file is, log the first few bytes. There's a reasonable chance that that will contain something a bit like a magic number. And then maybe once a month, once every 6 months, go through and identify the most common byte patterns and use that to work out where to spend your time. Don't just say, the first file that we couldn't identify was foo.bin, so let's work on that. You want to look at it and go, 3% of the files couldn't be indexed, but they all have the same byte pattern at the start. So maybe that's a whole new file format that we want to go off and add support in so that then we can index it better, search it better. If Tika knows what the file is but has no parser, then that's easy. You know, just log the MIME type and then go and add in a parser later. But a lot of what you'll come across, you'll be like, I don't actually know what this is, but I've got 10 million of them, so maybe it's worth spending some time finding out what's going on. So sometimes Tika will misidentify your file and will hand it off to the wrong parser. And so some of those files can then cause the parsers to do silly things. If you manage to break Tika with a file you can share, please tell us and we want to work on it. The problem comes is we sometimes get bug reports. Sometimes a document you can't have that I can't even find sometimes breaks things. Not really an ideal bug report. But if there's any of you out there who are crawling the internet, if you can come to us and say, sometimes this file here at this URL that's publicly available breaks, that's awesome because we can use that in a test case. We can build on top of that. But do be aware that every so often you will get an out of memory, you will get a hang. And if the file fails once because of one of these errors, and you're running on top of a clustering system, something like Hadoop or Storm, that's going to keep retrying, if the problem is with the file, then every time you give that file to another node, you're going to wipe out that node as well. So maybe you want to say, for these kinds of errors, just give up. But log it, because maybe when you upgrade to the new version of the library and we fixed that bug, then you want to retry all of those failed files. So I know some content management systems that build on top of Tika have a special marker where if they can't index a file, they put a marker in the database that says, there's stuff in this file that we can't handle, so that when you do an upgrade, you can then retry all of those files and see if you can now start indexing some more of them. So don't think of it as a permanent failure. Be aware that maybe in 6 months' time you'll be able to search those files. And especially if it was a file format that you couldn't identify before and you've now added support for, you're going to want to go through, re-add them into your index and expand your index coverage. And because occasionally Tika will break your JVM, seriously consider putting it in a separate JVM, separate process. But then if it's a very rare thing, maybe have a pool of Tika servers. If it's a really, really rare thing that you're calling Tika, maybe it's not the end of the world if every so often your JVM dies. But if you're making heavy use of it, if you're doing a web scale crawl, and a lot of the files you're coming across are going to be binary that you're going to be passing through to Tika, think about separating it out for when it all goes horribly wrong. Okay, this is a bit of an extreme example. The top is what it looks like in Adobe Acrobat. The bottom is what it looked like when sent through Apache PDF box when there was a particular nasty bug that was causing corruption. One of the things the PDF file format does to improve efficiency is it will remap some of the characters onto more common short forms so that it's a more compressed encoding. And then at extraction time, you have to go byte position 2 actually maps onto this file, this character here. And if that goes wrong, then you end up with garbage coming out. Rare, but not unheard of. And it's going to be hard if you're just blindly indexing it to then make sense of it. Another problem, don't know if you can see in the background here, this is from someone's CV. So that there is their statement of work, and then this is all of their job experience. Another PDF bug here. The bit in bold is all that we were able to pull out of this person's CV. It's very hard to search for missing text. Searching for a negative is hard. So if you were just running searches to check that data was coming through, it's going to be a really tough problem to spot that something's gone wrong and that you didn't get that piece of data in the first place. Obviously, you can't look at every single document you're indexing by eye and compare it side by side. But you need to be aware that if information has been lost, it's very hard to spot that. So, some of the things that will go wrong, I've already mentioned all the out of memory, the infinite hangs, memory leaks, running out of file handles and stuff. Exceptions are easy because you can catch them and log them. If there is missing text or missing metadata, that's hard to spot. Sometimes you'll get extra text. There was a bug recently in the PowerPoint extraction where we got a bit overzealous and started pulling through all of the placeholder information from the slide masters. It's not that bad, really, if you pull out extra information, but it can then mess up some of your counts. So if you say, oh, well, the most common word in this PowerPoint used to be buzzwords, but now it's insert text here, yeah, it's going to mess with your statistics. That's not too bad. The garbled text is a pretty bad one. Rare, but does happen. Within Tika, and hopefully within a lot of your applications as well, you're going to have unit tests. And they're going to tell you if anything really obvious has broken. But probably you're only going to have a handful of files available that you can test against. Really, you're going to want to run testing on a much larger scale. But if you've got 10 documents, you can check them by eye. If you've got 10 gig, you can't. And if you've got a terabyte, there's no way you're ever going to be able to check that except with another computer process. You need to be aware that file distributions are uneven. The kind of files that you are dealing with are not necessarily the kind of files that they're dealing with, are not necessarily the kind of files that are in my unit test suite. So something that will pass and go green for me is not necessarily going to be awesome for you. So you can't completely share the test systems, and you are going to need to check, even though Tika have released it and it's all gone green, and then Nutch included it and that was all green. That doesn't necessarily mean it's going to be error-free. So you're going to need to do automation of the running and of the analysis. So if it's just the number of exceptions, that's pretty easy because you can log them. Metadata is relatively easy because there's not much metadata about each file. So you can maybe log that for a subset of your files and then check between two versions that you're still getting about the same amount of stuff out. Attachment counts are easy. This Word document used to have 3 attachments now it's got none. Probably that's a bad thing, and something's gone wrong and you need to look at it. Junk text is relatively easy because you can look at the entropy and you can look at the common words. And if the common word for your document used to be forest and meadows, and now it's probably that's a sign that something's gone horribly wrong. Missing text is a real tough one. If you look at it by eye, you can spot that, but otherwise, how are you going to work it out? At the moment, for testing Tika, we're using GovDocs 1, which is from 2009, and therefore is missing a lot of the new file formats, and we're using some stuff from Common Crawl. But if any of you have large data sets of binary files that you can share with us, we'd really like them so that we can run the kind of automated analysis on them. One of the things that, where are we? One of the things we're doing is with the TKeval tool is we run for hours and hours and hours of machine time Tika at different versions and with different proposed patches in against large corpuses. And then we report the number of exceptions found and the occurrences of them, and we report the most common words for certain file formats, and then we check that between two different runs. So if someone proposes a patch, we can then see whether or not it is, on the whole, got better or worse. Which tends to mean, ideally, that we can catch a lot of these bugs which would cause the PDF to come out like that before we apply it and before you start deploying it onto your cluster. But if you've got a lot of custom parsers that you're adding in, a lot of custom file formats, you might want to look at running this and just look at the results and say, did it get better, did it get worse, how did it get better, how did it get worse? It's not going to tell you for certain if it's better, but it's going to give you a very narrow set of things that you as a human can go and check. The top 10 most common problems, the top 10 most common differences between these two things. That's great, because you can look at it and go, that's fine, that's not the end of the world, or we need to solve that one. You couldn't look at 1 million documents, but you can look at 10 common repeating failures and analyze that, and then decide what to work on. So whatever you're doing with your kind of analysis pipelines and so on, it is worth trying to summarize them, as you're going to have too many errors to look at. But if you can get a common subset together, and then once a month or once a week or once every 6 months, you spend some time and look at that, you can tackle the most important things and you can improve your quality that way, rather than picking one at random. TKeval Batch is what's powering TKeval. At the moment, it's only running on a single machine. It spawns off a whole bunch of different ones. There is work ongoing at the moment. We were hoping it was going to be finished now, but it hasn't been, to get it working on Hadoop, so that you could say, Tika, here is an HDFS area. I want you to run, do all the analysis, and give me a nice summary out afterwards. There's also some work going on to make it work on Storm, the same kind of thing. Here is 1 million documents, go off and process them and give me the text that I can then feed into an index, and give me the metadata that can go into the index and tell me what went wrong. If you're wanting to do that now and you're wanting to run on top of Hadoop, have a look at this wiki page here. It's got a whole lot of pointers. Or alternatively, just use Behemoth, which is a text indexing and processing suite that can also do some natural language processing at the same time, that starts off with very large collections of documents and outputs very large collections of useful information. Got about a minute left, so I'm just going to mention, these are some of the other Apache projects you might be interested in. Nutch is the Hadoop-powered web crawler and then indexing analysis. Storm Crawler, there's a talk on that a bit later on. That's looking to re-implement Nutch on top of Storm. NE23 is great if you've got a lot of triples, a lot of semantic data. OpenNLP and UEMA are great for the natural language processing. So once you've taken your Word document and you've pulled out some useful text, you might then want to do some sentiment analysis and find what sort of things they're talking about in this document. CTakes is great for anyone in the medical or pharma space. That takes things like OpenNLP and UEMA and has a training data set already available so that you can then just use it, batteries included. Don't know if there's any other ones people want to suggest. For non-Apache stuff, there's the Hardened Tika project. There's Behemoth. If you're doing any of the language detection and encoding detection, those three tools may be slightly better as well.